Hey, this video is going to be going over dividing rational functions. We divide rational functions just like how we divide regular fractions. And so we do that by using the keep, change, flip method. The keep, change, flip method tells us that we keep the first fraction as is. We don't touch it. We change the division into multiplication, and we flip the second fraction. We take the reciprocal of the second fraction, and then we just multiply as we do normally. So remember, we multiply straight across. So in this first example here, we have our first fraction, which we keep. Then we change multiplication. And then we flip the numerator and denominator of the second fraction. After we do that, this just becomes a multiplication problem. So remember, to multiply these, the first thing that we want to do is factor every numerator and denominator. So 4x plus 8, that GCF is 4, so I'm left with x plus 2. The 5x minus 20, GCF is 5, and I'm left with x minus 4. X squared minus 4x, that one has a GCF of x, so I'm going to factor that out, and I get x minus 4. And then the last piece, this one here, the 10 plus 3x minus x squared, this is written out of standard form, so it might be helpful to first rearrange. Negative x squared plus 3x plus 10. And after I do that, I want to factor, but notice that there's a negative in front of the x squared. And remember, we don't ever want a negative a when we're factoring. So what I'm going to actually do first is factor out a negative. So negative, and then I get x squared minus 3x minus 10. Now I can do big X. So negative 10 and negative 3. Negative 5, positive 2. So I get x plus 2 times x minus 5 with the negative in front. So that is my factored form for this one. Now, be careful with that negative. You don't want it to look like a subtraction sign. So don't forget that that is a negative 1, really. And that might actually be more helpful to write it as a negative 1 just for this case, so we don't think that we're subtracting these, okay? Now, before I go ahead and simplify this, I want to first find those excluded values. Now, excluded values, or the domain restrictions for a division problem, let's think about it for a second. We know that a fraction, right, 1 over 2, that's really saying 1 divided by 2, right? So when we are dividing by something, whatever we're dividing by, that is the denominator. We cannot divide by a 0. So in division problems, it's not just the denominators that can't equal 0. When actually it's the entire second fraction that cannot equal 0, because I'm dividing by this fraction. So there's actually 3 places that we look for excluded values when we do division. That is the denominator of the first fraction and the numerator and denominator of the second. So I'm going to look at all 3 of those places to find my domain restrictions or excluded values. So the first one here, 5 does not have an x, so it is not a factor that I need to worry about. The x minus 4, that one could equal 0 if I plug in a 4, so we're going to say x cannot equal 4. The negative 1, again, it doesn't have an x, so I don't have to worry about it. The x plus 2, so that equals 0. X cannot equal negative 2. The x minus 5, so x cannot equal 5. Then don't forget the numerator up here as well. So we have x equals 0, so x cannot equal 0. And x minus 4 equals 0, x cannot equal 4. And I notice here I have some duplicates, right? X cannot equal 4 is there twice. That's totally fine. You can list it twice. You cannot list it twice. I'm not going to fault you for that, as long as you have them all. So here are excluded values. All right. The next thing that I am going to do is simplify. So canceling out the factors that are in common, the x minus 4s, x plus 2, and that's it. So when I put together my simplified form, I have 4 times x in the numerator, so that's 4x, over 5 times negative 1 is negative 5, and then we've got the factor x minus 5. There is our simplified form. All right, let's do one more example. In this one, first thing I'm going to do is keep, change, flip. So I'm going to keep the first fraction the same. I'm going to change division into multiplication, and I'm going to flip the numerator and denominator of the second fraction. I am finding its reciprocal. All right, the next step is going to be to factor. So, again, I'm doing this kind of quickly in this video. If you need some extra help with factoring, make sure that you are attending tutoring. 8 and 3. Factoring is not going away anytime soon. Here we go, 35, negative 12, negative 7, negative 5. All right, to this numerator, the GCF is 2x, so x minus 7, and then the denominator here is 5, so x plus 8. Okay, next thing I want to do is find those domain restrictions or excluded values. Remember, it comes from all 3 places here, the denominator of the first fraction, and then the numerator and denominator of the second. So we have x cannot equal 7. X cannot equal 5, x cannot equal negative 8, and x cannot equal 7. Again, that's okay. You don't have to list it twice. You can. X cannot equal 0. Don't forget about that. X cannot equal 0 from the 2x here. All right, I'm going to cancel out those like factors, x minus 7, x plus 8. And then my simplified fraction, I have the 2x and x plus 3 in the numerator over 5 and x minus 5 in the denominator. You don't have to move the 5 first, but you can if you'd like. All right, use this video to help you understand division. Go ahead and try some of the practice problems in your packet.